Okay, welcome back. Now we're going to do inverse variation. Okay, if y varies inversely as x and there's some non-zero constant k, then we're just going to have y equals k over x. So y equals k over x. Notice that these are all the same. Whatever varies goes on the left. K is always on top. It's never going to be on the bottom of a fraction. And then inversely just means whatever is varying inversely goes on the bottom. Okay, so instead of x going on top like it was jointly or directly, it's just going to go on the bottom. All right, and these graphs over here are just an example of what a graph of inverse variation would look like. So here we have if A varies inversely as B and A equals 3 when B equals 8, find A when B equals 6. Again, whatever varies goes on the left. So if A varies, we have A equals K, and it's inversely as B. So B goes on the bottom. Okay, so again, we have to find K. So we have 3 equals K over 8. So 24 must equal K. We can rewrite our equation now. So we have A equals 24 over B. Then it says to find A when B is 6. So A equals 24 over 6. A equals 4. And it's as simple as that. Go ahead and try the next one. When you come back, I'll show you the solution. All right, R varies inversely. So we have R equals K over T. Okay, always, always, always write that first or you will run into problems. Okay, so then R equals -6 when T is 2. So we have -6 equals K over 2. So -12 equals K. All right, we can rewrite our equation. R equals, almost wrote K, -12 over T. And then it says to find R when T is -7. So we have R equals -12 over -7. Can't really simplify that, so that's our answer. We can get rid of that negative though. We'll have 12 over 7. And that's our answer. All right, combined variation. Okay, this is when one quantity varies directly and or inversely or also jointly as 2 or more other quantities. So basically, if we have y equals k times x over y, whatever varies goes on the left, just like we said earlier. We're always going to have constant. And then if it's directly or jointly, it goes on top. And if it's inversely, it goes on the bottom. I think I spelled inversely wrong, but that's okay. All right, so whatever varies goes on the left. We always have our constant K. And then if it's directly jointly, it'll go on top. And then if there's an inversely, it goes on the bottom. Again, setting this up is going to be the hardest part. Actually solving the numbers is not too difficult at all. Okay, so if you have anybody around you, you can try and think, pair, share with this one. Otherwise, just try it on your own and I will show you the answer. All right, so if f varies directly as g and f varies inversely as h. Okay, so whatever varying goes on the left and we always have k. If it's directly as g, g goes on the top, and if it's inversely as h, then h must go on the bottom. And now it's just a matter of solving. So find g when f is 6 and h is -5. So we have g equals 18 when h equals 3 and f equals 5. So we have 5 equals k, 18 over 3. So we have 5 equals k times 6. So 5 over 6 equals k. So we can rewrite our equation as f equals 5 over 6 times g over h. Okay, and then we have our points. Find g if f equals 6 and h equals -5. So we have 6 equals 5, 6. times g, because that's what we're solving for, over negative 5. All right, simplify a little bit. So 6 equals negative g over 6. Okay, because that 5 and negative 5 cancel and just give me a negative. So I'll get 36 equals negative g. So negative 36 equals g. And that's your final answer. All right, just a matter of setting it up. If f varies directly, then f is on top, and there's k, and g is directly, so it goes on top, and inversely is h, so h goes on the bottom. And then you just got to plug points in. All right, and this last slide just shows you the different types of variation. In summary, there's direct, inverse, joint, and combined. Please read through those as a summary and to make sure you understand. Okay, that's pretty much it. All right, those are the different types of variation. Okay, once you feel okay with this video and you understand